from the National Weather Service office in Lake Charles, Louisiana, I'm meteorologist Donald Jones. Now, don't freak out. For those of you who have seen our broadcast before, we do not have any kind of a tropical threat at the moment, but it is the official start of hurricane season. Being June 1st, we are on day 1 now, and we're going to go all the way until November 30th, which is the official end of hurricane season. Now, we don't have any threats to our area immediately, but we do already have an area of disturbed weather that we're watching for some possible development in the southeastern Gulf of Mexico here over the next couple of days. The good news is, as I said, it's not going to affect our area at all, but we did want to take this opportunity, being the first day of hurricane season and with a tropical disturbance potentially getting into the Gulf, to kind of talk about what to expect as far as the entire season as a whole. So we're going to talk about the long-term outlook for the entire Atlantic hurricane season. We do put out a seasonal forecast for those of you who may not be familiar that discusses how many storms we expect over the course of the season. And that's actually issued not only by the Weather Service, but also through university. Colorado State University puts out a forecast for that as well. We're going to talk about that just as soon as we get through talking about our storm system here. And I've got with me Joe Ruitt. He's one of our senior forecasters here at the Weather Service in Lake Charles. He's been here for many, many years, been through many hurricane seasons, and is a wealth of knowledge and information about our local tropical program here. So we're going to talk to him. He's going to have a little presentation for us here just as soon as we wrap up this briefing here. And then, of course, as always, we'll answer any weather questions you have. So feel free to post them in the comment section, and we'll answer them over the next little while. I just want to run through here and talk real quickly about this is actually the remnants of a hurricane that was in the eastern Pacific this past weekend. It actually came ashore across Central America and has kind of been moving through the very mountainous terrain of Central America. It really broke down, and right now it's just a remnant low, but it's going to be reemerging out over the southern Gulf of Mexico here over the next day or two, and there is the possibility of it redeveloping into some kind of a named tropical system over the next day or two. Again, that formerly was known as Agatha. If it does redevelop, it's actually going to get a new name because it's crossing basins from the Pacific into the Atlantic. So if it does reform into a named tropical system, it would get the name Alex. That's the first name on the Atlantic side's hurricane list for this year. Now, conditions aren't particularly favorable for development of this system. There is a fair degree of wind shear, and sea surface temperatures, they are warm enough, but they're not obscenely hot. It is very early in the season. So conditions are marginally favorable for development, but not any kind of rapid intensification. So if this does form, it's going to be very slow to do so. It's been torn apart by the mountains of Central America for the last couple of days. So if it does develop, it's likely to develop into a tropical depression, maybe a tropical storm, before moving inland across parts of Florida, most likely here towards the latter part of the week. But as I said, no impacts are expected across our region, Southeast Texas or Southwest Louisiana, with regards to it. This is the remnants of Agatha, just now a kind of little weak area of low pressure. There's kind of two areas of low pressure, one over here over the Bay of Campeche and another one moving into the kind of Caribbean. We'll see which one of those kind of becomes the actual center of circulation. This whole system is going to be moving generally to the northeast towards Florida over the next couple of days. Models have been in pretty good agreement with regards to that for the last several days, and there's no reason to think that's going to change anytime soon. Once it reemerges over the southeastern Gulf, there will be the opportunity for some development that could happen anywhere within this area here. Now, keep in mind that this is not a cone of uncertainty. This does not say anything necessarily about where the storm is ultimately going. This is just the area that we could potentially see some tropical development. Although, coincidentally, it does look like this is going to be kind of the path that's going to be taken here, kind of southwest to northeast into parts of the Florida Peninsula, and then eventually up the east coast, bringing likely a whole lot of rainfall. That's going to be the biggest threat with this system, not so much the wind, but the potential for flooding, heavy rainfall, maybe a tornado threat as well. Now, as I mentioned, conditions are only marginally favorable. There is a lot of dry air across the northern Gulf of Mexico. It's not really moving in that direction. It's going to be moving up this way, but there's going to be a lot of dry air moving into this storm. That's going to kind of limit development. There's also a lot of wind shear across the southeastern Gulf of Mexico. That's going to be continuing to kind of blow the storm apart. So I don't expect any kind of real significant intensification with this system over the next couple of days. Slow intensification to a depression, maybe a low-end tropical storm. That's probably going to be about it. Sea surface temperatures are, however, warm enough in the Gulf of Mexico. Those temperatures in the Gulf are running above normal for where we expect them to be this time of year. Usually we expect them to be right at about 80 or so. but running between about 80 and 84. That's because we've had this big area of high pressure sitting over us through much of May. That's allowed temperatures to really warm up. We had a much above normal May in terms of temperatures across our region, and that has extended out across much of the Gulf of Mexico. So temperatures across the Gulf are running well above normal. So that is something that it has going in its favor, but that is really the only factor that it has going in its favor at this point. But again, not expected to be a threat anywhere across our region over the next 7 days. In fact, save for a few isolated showers and thunderstorms, which we do have out there today, and maybe 20-ish% or so as we go through the end of the week. Really not a whole lot to talk about. Early next week, we're going to be dry, and it's going to be warm out there. It is going to be the first part of June. After all, it is very summer-like. May have a few of those afternoon showers and thunderstorms, but otherwise hot, dry, sunny, humid. Not my type of weather, but we get what we get this time of year. That's going to be about the status quo, save for any kind of tropical systems now through probably late September. So that's what we have here as far as the tropical system that we have going on right now. I'm going to introduce now Mr. Joe Rua, again, senior forecaster here with the National Weather Service in Lake Charles. He's going to discuss what to expect as far as the remainder of the tropical season, and we can always cross our fingers and hope that this forecast is 100% wrong. With any luck, this is the last time you'll have to see my beautiful face here, at least through the end of November. So I'm going to bring in here now Mr. Joe Rua.
Okay, thank you, Donald. Like Donald said, I'm Joe Rua, the lead forecaster at the National Weather Service in Lake Charles. So the rumors were correct that I am the special guest. I'm kind of old as dirt around here, usually behind the scenes doing the forecasting, but they brought me out in front of the camera to talk about the hurricane season upcoming. Well, let's go ahead and get right into it. Let's look at our outlook. So this is the prediction that we've come out with from NOAA. So basically we have a 65% chance of above normal activity during this hurricane season, 25% chance of near normal, and 10% chance of below normal. So what that comes out to be basically is about 14 to 21 named storms, 6 to 10 of those hurricanes, and 3 to 6 major hurricanes. And a major hurricane is basically a category 3 or higher. Now let's look at some of the other sources out there that do these tropical seasonal outlooks besides just NOAA. Colorado State, which kind of pioneered the seasonal outlook, they also came out with their outlook about 19 named storms, so above normal activity, 9 hurricanes and 4 major hurricanes. Now, tropical storm risk, they're out of Great Britain. There are basically academics out there that deal with the insurance agencies. So they come out with an outlook every year also. Once again, theirs is above normal, 18 named storms, 8 of those hurricanes, and 4 major hurricanes. And then our friends at the European Meteorological Organization, they came out with their prediction. And once again, it's above normal, 16 named storms, 8 hurricanes. So basically everybody out there who does any sort of seasonal outlook is looking at above normal activity this year. So basically, why is this happening? Well, first of all, let's look at our percentages. So what does those numbers mean? 14 and 21 hurricanes and so forth. So what we do, we kind of, Colorado State University fortunately has a tropical cyclone impact probability. So we take number of hurricanes where tropical storms are expecting this year, crunch the numbers and see what your probability is for your location. So basically for anywhere along the state of Louisiana or state of Texas coastlines, within 50 miles of that, you have about an 8 in 10 chance of seeing a tropical storm this year, and about 1 in 2 chance of getting a hurricane. And pretty much those numbers are above normal. You get about a 2 in 3 chance getting a tropical storm, and about a 1 in 3 chance getting a hurricane. Now for major hurricanes, that's category 3 or higher. The probability along the Louisiana-Texas coast this year is about 25% or 1 in 4. And normally it's about 1 in 6. So once again, our risk probability is increased along the Louisiana-Texas coast. Now let's look at that even a smaller impact, because we live in Southwest Louisiana or South Central Louisiana or Southeast Texas. So what's the probability for that location? And for Southwest Louisiana and South Central, Southeast Texas, pretty much very similar. We're looking at a possibility of a 1 in 2 chance of seeing a tropical storm within 50 miles of our coastline. Normally we have a 1 in 3 chance, so obviously it's a little bit increased this year. For a hurricane, it's about 1 in 4 chance, normally 1 in 6 chance. So once again, a little bit slightly increased. And for a major hurricane, about 8% chance. You only have about a 5% chance of getting a major hurricane within 50 miles of Southwest, South Central, or Southeast Texas. So those are kind of low probabilities, right? 25% chance of a hurricane. Does that really matter? Should I really get prepared or not for a situation of a 25% chance of it happening? Well, what we have right here is a low probability, high impact event matrix. So this is what we kind of look at, telling people what they need to prepare for or not. On our impact side, that's a scale pretty much damage. So it goes from minimal damage up to severe and major damage. And looking at the horizontal, it's pretty much in the probability of being either rare or almost certain. So that's your probability scale. So even for rare or unlikely events, if it's going to have severe or major impacts, we need to prepare for it. And that's what we're looking at right now. Kind of a hurricane situation, maybe a low probability, but the impacts are going to be very severe, very major. So we're in that risk matrix that we need to prepare for the hurricane season. Another way to look at that for why low probabilities matter, let's say we're forecast like today, 20% chance of rain. You kind of get rained on. Well, it's a little bit of inconvenience, right? You got to get out the umbrella. Maybe you have to wait to mow the grass. So it's not maybe that not big of a deal for rains. We're only forecasting 20% chance. Unfortunately, if you have a 20% chance of hurricane force winds and hits your area, obviously the scenes can be devastating. So that's why that low probability for high impact events still matter. So now let's look at why we're going to have this active hurricane season. At least that's what everybody's predicting. Well, one thing, we're beginning with the hurricane season on a La Nina event. Basically, La Nina is the cooling of waters in the Eastern Pacific. What that does, it creates less vertical wind shear across the Atlantic and the Caribbean, which allows these waves to have the potential to form more than if they had strong vertical wind shear. Now, there could be a transition to neutral late in the season. If that does take place, then that will have an impact for the number of Gulf of Mexico systems, and we'll talk about that here shortly. Right now, there's above normal sea surface temperatures throughout the Atlantic, Caribbean, and the Gulf of Mexico, so that will obviously add to the possibility of having an active season. There's also something called an enhanced West African monsoon, and we'll talk about that here shortly. So here's just the graphics of the sea surface temperatures that are occurring. So basically, to start the year, you can see how the below those blues out there show below normal sea surface temperatures. So there was a cooling out there in the East Pacific, and as soon as a couple of days ago, we still had that cooling out there. So basically, we're in a La Nina pattern. So basically, we've been in that pattern for a few months now, and it looks like it's going to continue. Now, also to draw your attention to the sea surface temperatures here in the Atlantic, Gulf of Mexico, and Caribbean, those are in the yellows and reds. So we do have above normal temperatures already out there. So let's go ahead and look at the, as soon as these, here we go, for the West African monsoon event. So basically, West African monsoon develops from June through September. And already, looking at the latest rainfall data out in Africa, we already have a lot of moisture out there. So the monsoon season is pretty much already beginning. And so far in this, or the forecast for this year is that this monsoon is going to be enhanced. So what that does is it allows these tropical waves that come off the African coast to have moisture with them, not be those dry, tear and dust type events. These are going to have a lot of moisture with them, tropical moisture, and that will allow them to have a better chance of developing if they were not as moist. So let's look at kind of the seasonal patterns and how they affect the number of systems in the Gulf of Mexico. So once again, let's look at what we're at right now. We're in a La Nina pattern. So for La Nina, normally we have quite a bit of activity as far as tropical systems in the Gulf of Mexico, and pretty much a decent number of hurricanes and even major hurricanes. Now, if we switch over to La Nina into a neutral pattern, which is somewhat the forecast is saying maybe by peak of hurricane season of September, October, the number of hurricanes go down significantly. So that's a big deal if we transition to neutral or not. Now, basically our biggest hurricane events and tropical storm events, actually, if we start at an El Nino and go to La Nina late in the year, so that's when normally we have most of our activity, our biggest activities during that time frame. But once again, what we're expecting this year is La Nina to neutral. So hopefully we do go in that neutral pattern. That will significantly reduce our possibility of getting storms in the Gulf of Mexico. Well, now let's go ahead. We've looked at the outlook, so let's look at the guidance. So a lot of people always want to know what's the guidance showing when something is going to develop in the Gulf of Mexico or the Atlantic. Everybody's like, what's the guidance showing? What's the guidance saying? And so forth like that. So how good is the guidance? And what do we use for guidance here at the National Weather Service? Well, actually, if you're looking at this, these are official verification numbers we get from the National Hurricane Center. And over the past few years, this dark solid line is actually the official forecast that they make. And as you see right here, that skill level is a lot better than any of the global models. So the global models like the GFS model or the quote unquote American model, the European model, UK Met model, so forth. They're all down here basically of a lower skill, just using one model run, than if you use the official forecast, which is very close to the consensus models. So like the Florida State Super Ensemble, the HECA model, and so forth. These are all consensus models that are run, and those official forecasts and consensus models do a lot better skill-wise than just one global model run. And to back that up, here's the kind of the raw numbers from last hurricane season, and this is track guidance errors. And as you can see right here, consensus models were the best at each time frame, and even at the 96-hour time frame, actually the official forecast from the National Hurricane Center was the best out there. So as you can see, the official forecast and consensus models are better than just using one global model during an event. And actually, the Hurricane Center did very good last year. Here is the 5-year average, and you see they beat that at each time frame. So last year, the Hurricane Center, National Hurricane Center did a really good job forecasting the tracks of tropical systems. Now let's go ahead and look at the intensity guidance also. And pretty much, once again here, the dark solid line right there is the official forecast. The dashed lines are the consensus model forecast, and the solid colored lines down here are the global models. And once again, the official forecast had the better skill, and the consensus models had a better skill than just the global model runs. So once again, official forecast kind of beats everything else. And once again, here are the raw numbers to back that up. Even at the 24-hour and the 72 hours, once again, the official forecast was the best of all the guidance out there, and consensus models were well above anything that the global models showed at each time frame. So basically what we're saying here is that the official forecast and the consensus forecast is the best way to go for guidance than anything else. Now, why is this true? Why is consensus modeling considered better than anything else? Well, it goes all the way back to 1906, where the wisdom of the crowd theory came about. And so Sir Francis Galton, he's an English statistician and also considered one of the first meteorologists in the world. He attended a county fair over there in England back in 1906. And what they're doing, they're having a contest. They're saying, who can guess what the weight of an ox is? And you do that, and you win a prize. Well, no one won the prize, so no one guessed it correctly. But Francis Galton there said, hey, to the person who's putting on the fair and the contest, I want to see all your guesses. Let me see all the guesses. So there was 800 people that guessed on the weight of the ox. He figured out what the mean of the guesses were, and it was 1,207 pounds. So the actual weight of the ox was 1,198 pounds. So it was within 1%. So that's came up, hey, well, how does this work? So we kind of came up with the wisdom of the crowd. You take all the guesses, which would be all the model data, and put them all together into one consensus, and you get a forecast. And normally, and it's been pretty proven over and over again, that consensus forecasting, instead of just using one model run, is better than anything else. And so that kind of comes back to the wisdom of the crowd theory. Now here's something also very important when it comes to guidance, and I see this every year also, and we've already started this year, even before hurricane season started, was the social media hurricane hype. And basically what this is that someone out there gets those one model runs and shows, uh-oh, look at this, a hurricane coming into the Gulf of Mexico, and this is like 2 weeks out. Well, as we just showed you there, official forecasts are better than anything else. The consensus model is better than anything else. So these computer-generated just one model runs that show a hurricane impacting the area like 8, 10, or 2 weeks out, they do not provide really any context or explanation of what's going on. And also, they seldom become reality. There's just really no skill that far out. So don't buy into sort of hype like this. So get your information instead from reliable sources, and avoid what we call these keyboard meteorologists out there that like to share these one model runs of something way in advance, just to create hype and make predictions beyond the current science, so they can get likes and shares on their social media pages. And like I always say, once again, if there is a tropical threat out there for the local area, rest assured that the National Hurricane Center and us here at the National Weather Service Office, like Charles and Donald himself, will be out here doing the Facebook Lives. So that's the best way to go right there, because what we do here, we basically say is we want to have the right people take the right action for the right outcome. So our job is pretty much to protect life and property, not to get likes and shares. This right here, right? I get this meme every single time something's about ready to develop. this is how you guys are predicting, right? Using all those spaghetti models out there, you just pick one, and that's what the forecast is going to be. Well, let's go ahead and talk the spaghetti models here. Basically, when we come to the National Weather Service, we kind of use extreme caution, and basically we discourage from using it. So in our briefings, we really don't use spaghetti models. Basically, what we're looking at right here is like we said, just a lot of these are not even real guidance. They're pretty much just markers for verification. They're based on climatology, not even based on the situation that's happening at the present time. So you really get like not a really good picture of what's going on, not the most accurate picture. And a lot of times, like the Florida State Super Ensemble is not used on spaghetti plots because for proprietary reasons. It's owned by a private company in North Carolina now. And so they don't allow those who out their forecasts go out on the spaghetti plots to the public. And you really can't see continuity from one run to the next. So it's just a bunch of kind of mess out there. And unless you really have the experience of dealing with each of these models, you don't know which one has the better performance, which one is performing better in this situation, and so forth. So it really doesn't show the strengths and weaknesses of each model trend and so forth. So we really encourage not using briefings for spaghetti plots. So you remember the old Seinfeld episodes with the mean soup guy, and you line there and you go up there and you say, "No soup for you." Well, we have to, at the Weather Service, say no spaghetti plots for you when we're doing a briefing. So once again, just go over some of the guidance here. The official forecasts are really the best to go with, and they're right along with the consensus global models. And so consensus makes for the best forecasting. And like I said, here in the National Weather Service, the National Hurricane Center, really we've bought into consensus forecasting is the way to go. So the official forecasts have proven that over the past several years. Once again, the spaghetti plots we don't really encourage using or looking at. And also, once again, do not look at just one model run. We just showed it pretty much that the stats back it up. The official forecasts and consensus forecasts are the best way to go, the best way to look at. So basically, wait for the official forecasts and follow the official forecasts. So let's look at now some of the key Hurricane Center products that we issue and that we look at and we use in our briefings here to kind of interpret how we interpret those properly and how to understand them. So the tropical weather outlook. Now, Donald already did a good job of this. The first tropical weather outlooks of the year have already come out. And so basically, what does that tropical weather outlook show? Well, basically, it's going to be a formation, potential development in the next 2 or 5 days. So that's the way to look at using the tropical weather outlook. And each color code is basically a shading for the probabilities. So a low chance would be shaded in yellow, and high chances would be shaded in red. Now, also what Donald said is that the shading area does not necessarily mean the track. It just means where the location for it to form is going to be. Now, sometimes they do kind of match up with eventually what the track is going to be, but there's been situations where you kind of like develop somewhere and it'll actually go, to the north and so forth. So it doesn't necessarily use this as a track. Just use this as a representative, say, all right, there's something to look at in this area. We better, pay attention, keep an eye on it. And so pretty much like for example here, this was last year with Hurricane Ida. And you see the potential area for development was way down in this area here, but obviously we know that it came pretty much up, developed further to the east and went up into Louisiana. So this is 6 days before landfall. So the other thing is, and early on in an event, sometimes these are low confident forecasts, and a lot of errors are made when it's initially that far out in advance. I should say also the tropical weather outlook is issued 4 times a day from the National Hurricane Center at 1 a.m., 7 a.m., 1 p.m., and 7 p.m. So basically those updates will come out every 6 hours unless there's something really special happening. So when you see a tropical weather outlook at about 7 a.m., know that we're not going to get another one until 1 p.m. in the afternoon and so forth. So in the afternoon, around 1 or 2 o'clock, know that you're not going to get another one until about 7 o'clock in the evening. And here's an example like I was talking about Ida. So like here was about 3 days before landfall. So now we see that the formation area now is shifted to further to the east there. So it's going to develop somewhere in this area, and that's what happened. It developed up here just off of Cuba, and eventually then did track off to the northwest into Louisiana. Okay, now the most popular product that the National Hurricane Center puts out is their forecast cone product. So there's a lot of confusion a lot of times using the cone product and so forth. So we'll try to how to interpret that here. Now, a lot of people call this the cone of uncertainty. Well, it's more likely the the cone of probable track of the center. That's basically what it is, because what it is, it's based totally on statistics. So each point of the cone here is basically 66% of the time, the center will be within that cone area. So basically, it's the probable location of the center of the system. Now, it also does not indicate impacts. And we'll show that here in some of the examples, that impacts can be well outside the cone. And actually, if you actually wanted to know what the cone radius is, this is what it is right here. So for this season, and for every single system, no matter if it's a hurricane, tropical storm, tropical depression, whether it's a really large system, it's a very small system, whether we have really great confidence in the forecasting and all the models are right on the number, or they're well spread out, the cone is always going to be the same. So that's something that people get confused about, but the cone does not change for each system. It's always the same. So it's the same at the beginning of the event, towards landfall, the cone is always going to be the same. And so for example, at 24 hours out, the cone is going to be 39 miles radius for the cone, no matter what the system is. We could be pinpointing exactly, we know exactly where it's going to be 24 hours out. The cone is still going to be 39 miles out for the center of the location. Now, what's interesting here is that in the past decade or so, the cone is getting smaller. So basically about a third smaller now, like 28%, 39% smaller. So basically, we like to say the cone has been on a diet. So it's been losing weight, it's getting smaller, but hurricanes are not getting smaller. Hurricane systems are not getting, not on a diet. The impacts are occurring just the same. So now the possibility of impacts occurring outside the cone are more than they were before. So here's just some common cone misconceptions. So basically, let's say the cone represents the uncertainty for this particular storm track. No, that's incorrect. The cone will be the same for all storms and scenarios for the entire hurricane season, and there'll be no changes in the cone for the size, strength, and track of uncertainty. So basically, the cone is going to be the same, basically we're saying here. And also, the cone represents the area of expected impacts from the storm. Once again, that is no. The impacts are felt outside the cone on a regular basis, and warnings usually extend outside the cone. So we always need to remember, think about the impacts, and what you're underneath as far as your warnings go. So the forecast cone product is issued 4 times a day with the big advisories that come out from the National Hurricane Center at 4 a.m., 10 a.m., 4 p.m., and 10 p.m. Central Daylight Time. So for instance here, this was last year with Hurricane Ida. And we can see right here, once again, the cone. So the cone product comes up in here. This is what the probability, likelihood of the center of the location being. You can see right here, the impacts, we got warnings already outside the cone for Southeast Louisiana into Southern Mississippi and Southern Alabama. So those people who thought, oh, we're outside the cone over in this area, we're okay. Well, you actually have a hurricane warning out. So it's something important to know. And even as we get close to landfall, obviously the cone is going to get smaller, closer to landfall. So once again, we got warnings well outside the cone area right there. So that's something very important to know, is that just because you're outside the cone doesn't mean necessarily you're not going to see anything. So once again, just to review the forecast cone product, basically we want to use this to get the overall idea on the trend of a tropical cyclone. So overall, where the center is moving. Also, basically, it's going to show the probable location of the center of the tropical cyclone. So not necessarily the cone of uncertainty, but the probable location of the center. That does not show the size of the system or the expected impacts. So we want to look at the products that show the impacts, and we'll go over those here shortly. And once again, the cone is going to be the same for each tropical cyclone during the year. So just remember that. So let's get into some of those impacts. Let's look at the tropical wind hazards. And so really the best product to use for that is the wind speed probability product. And this will be how likely you're going to get tropical storm severe winds. Like when you issue severe thunderstorm warnings, it's 58-mile-per-hour winds. So basically how you're going to get those severe winds, and also the probability of getting the hurricane force winds. And also basically when those will arrive. So basically what happens is there's about 1,000 ensemble members out there for a reasonable location. So they basically use the official Hurricane Center track, and they put in 1,000 different scenarios, and they come up with a bunch of lines and forecasts of where the center might go, when it might go, or how soon it might get there, and what the radius of the winds are going to be. And so from all that, they come up with a probability for a location of what your chances of getting a tropical storm, severe, or hurricane force winds are. So for example, here's your tropical storm force wind probability product. And once again, this comes out the same time as the cone product, the same time when the major advisory comes out at 4 a.m., 10 a.m., 4 p.m., and 10 p.m. Central Daylight Time. And as we can see right here, it'll give you the swath, the probabilities of getting tropical storm force winds. So you can see how the cone product was much smaller, and you might have probabilities outside the cone. So that's why it's very important to look at this product right here, not necessarily just the cone. Basically use this in conjunction with the cone for the wind product. As we get closer to the event, you can see how the probabilities are increasing, kind of where the strike zone is, where the most likely chance of getting those tropical storm force winds are going to happen. So it looks like basically in this far event, it's like 3 days out from Ida, we had actually a medium chance of getting tropical storm force winds in southwest Louisiana. But as we went into time and got closer to the event, you see how the center was going to pretty much going to southeast Louisiana now. So the probability is greatly reduced there in southwest Louisiana for getting tropical storm force winds. And the large area tropical storm force winds probabilities really was striking southeast Louisiana into southern Mississippi. If you remember looking at the cone there, especially before landfall, the cone was pretty much just in this area right here, a very small area. So these probability for tropical storm force winds was well outside that cone. So that's why you want to look at this probability product. And the same thing goes for the hurricane force wind probabilities, issued exactly the same time the tropical storm force probabilities are issued. And once again, this was like a couple of days out before the event. You can see that there's hurricane force probabilities throughout Texas into Mississippi, with the strike zone kind of there in south central Louisiana, where the most probable location of the center was going to be. And as we got closer to landfall, we see that once again, the hurricane force winds, no probability to get into southwest Louisiana or east Texas this time. Everything was being strike zone right there in southeast Louisiana. So once again, the best way to use this product, also the arrival time is very important too. And this is issued the same time the tropical storm probabilities come out. So what we're looking at here is kind of the most likely arrival time. So based on the official forecast from the National Hurricane Center, what time will the tropical storm force winds reach your area? And this is done basically for preparation purposes. You want to get done with your preparations before tropical storm force winds affect your area. Also, a lot of times emergency management officials will issue evacuation orders before tropical storm force winds get there. And also a lot of operations will be shut down once tropical storm force winds get to a location. So tropical storm force winds are very important. And so that's why a lot of our users out there, the public, emergency management officials need to know when they're going to get tropical storms. So at this example right here, at 8 a.m. Sunday morning, tropical storm force winds would reach southeast Louisiana. So basically, if the official forecast is right on the money, exactly perfect, that's what time you needed to be prepared and done your preparations by 8 a.m. Sunday morning. Now, as we all know, there's a little bit more intensity than that. So we have also is the earliest reasonable arrival time of tropical storm force winds. And at this example, you saw it was 2 a.m. there getting to southeast Louisiana. It's about a 6-hour difference there, 6 hours earlier. So how to use this product is like if you really want to be prepared for maximum safety, you look at the earliest reasonable arrival time and say, I need to be done with my preparations by this time. If I'm done by 2 a.m., then I know I'll be ready to go when the tropical system affects our area. So once again, how to use this wind speed probability product. So we use this to see a probability for a location if you're going to have the impact of tropical storm, severe hurricane force winds. And you also use it to see the most likely, the best forecast, and the earliest reasonable time, which is to prepare for maximum safety of arrival of tropical storm force winds. And then you know what you do, you look at each product. Each time it comes out, is your probability for your location increasing or decreasing? So that knows that you're kind of like getting closer to the event. It means that if your probabilities are increasing, the more likelihood that you might be affected by the tropical storm or hurricane force winds. And also, if the arrival time is getting sooner, that means you have to, all right, now it's time we need to really make those preparations sooner than we did earlier. So basically, that's the way to use the probability product. See if your location, if they're increasing or decreasing. Now, here's also very important to know the difference between warnings and watches. So basically, a hurricane watch we've issued first if we think that there's going to be sustained winds of 74 miles per hour or higher possible within the next 48 hours. So within 48 hours, if there's a possibility of hurricane force winds in your area, you'll get a hurricane watch. Now, these sustained winds of 74 miles per hour or higher are expected within the next 36 hours. Then you'll get a hurricane warning. And so how do we do that for preparations? So the hurricane watch is issued, hurricane possible. That means go ahead and start preparing your home. You'll board up the windows, move the loose items that you have outdoors, indoors, get your emergency supply kit ready and so forth. And if a hurricane warning is issued, that means it's time to seek shelter or it's time to evacuate if you're ordered to evacuate. And it's exactly the same thing for the tropical storm. Tropical storm watches are sustained winds between 39 and 73 miles per hour. And a watch will be issued when these conditions are possible within 48 hours. And tropical storm warning is for sustained winds between 39 and 73 miles per hour expected within 36 hours. So once again, warnings means they're expected and watch means they're possible. Now in the event, unfortunately, like we did with Hurricane Laura, when we have an category 3 or higher making landfall, and the sustained winds of 115 miles per hour are expected to occur within an area, we will issue an extreme wind warning. And what this is done for is basically the shelter within a shelter. So a lot of times people might not evacuate because they're not going to be affected by the storm surge, or for some reason they just can't get out in time. If they're still in there, this will tell them that the catastrophic winds are about ready to happen. So you need to get within your shelter, You need to get in that area that's away from windows, that center part of your location of your house. Get on that helmet, get on the pillows and the mattresses and so forth to cover yourself, because you're about ready to get that catastrophic damage what a lot of homes cannot withstand. So next up is our storm surge hazard. And basically what the National Hurricane Center puts out is the potential storm surge flooding map. And this will come out once again the same time as the cone product and the wind probability products. Basically when the main advisories come out at 4 a.m., 10 a.m., 4 p.m., 10 p.m., you also get a storm surge map, which basically shows the probability of your location, what the height above ground level will be of storm surge. Now, basically, this is based on the National Hurricane Center official advisory. So it's issued approximately 48 hours before arrival of the tropical storm force winds. So basically, this is going to, since there's so much uncertainty in the track location, size, and forward speeds, and intensity, it all goes into figuring out what a storm surge will be, that we, about 8 hours out, we're pretty much got a better handle maybe on the situation. So we'll produce those maps right there. So people, emergency management community will know if they need to make evacuations or not. And basically a lot of the uncertainties are based on the historical areas to go along with what the track location is for the current system. And once again, storm surge, that's inundation above ground. And when we get to like about 3 to 6 feet above, if we got this graphic right here, about 3 feet above ground level, we can see like most people cannot handle 3 feet of water or higher. So that's when we'll go ahead and start issuing the storm surge warnings and watches. So a watch is the possibility of life-threatening storm surge, that's 3 feet above inundation or above, within 48 hours. And a warning means that the danger for life-threatening storm surge flooding within 36 hours. So once again, the possibility is the watch, the danger is the warning. And a lot of times, since evacuations need to happen 48 hours out, normally a storm surge watch will be issued. Then they'll go ahead and trigger people to go ahead and issue evacuations for the coastal areas. Now let's get into our hydrology and flooding issues that we have with tropical systems and hurricanes. And our partners at the Weather Prediction Center help us out a lot with that. They're kind of the rainfall experts and so forth. So we get a lot of their information from them. We do a lot of collaboration with them also. So for example, when we're doing the rainfall forecast, they'll collaborate with us. They'll talk to us at National Weather Service like Charles says, hey, what do you think about the rainfall for your area? Let's get on the same page here, get the same numbers out. And these will be issued basically around noontime, midnight. And there'll be the initial issues. So that's when we'll start collaboration with the National Weather Service offices. And they'll actually be updated about 3:30 and 3:30 p.m., 3:30 a.m. is when the official forecast for rainfall amounts come out. And these will go all the way from just a day one forecast out to 7 days out, how much rainfall can occur. Now let's think about that. Does rain really convey the whole impact, the whole threat? Well, let's say we're forecasting about 5 inches of rain. But 5 inches of rain is going to fall gently at the same rate over the whole day, whole 24 hours. Well, let's say the 5 inches of rain is going to fall in an hour, 2 hours. With some of these tropical systems, you can get like 3 to 5 inch rainfall rates per hour. Well, obviously that will overwhelm the system a lot more than the 5 inches of rain gently over a full day. So there is some context that needs to be put in when it comes to rainfall amounts. So to convey that message, we have something called the excessive rainfall outlook. And once again, this is put out by the Weather Prediction Center, and they'll coordinate with the National Weather Service local offices also to try to pinpoint where these excessive rainfall is going to fall. Now, what that definition is excessive rainfall leading to flash flooding within 25 miles of a location. And these are issued pretty much several times during the day. They always go out from day 1 all the way out through 5 days out. And pretty much here's the interpretation of it. So with this, once again, we have a scale, risk scale, going from marginal, which is on the low end, category 1 risk, all the way up to high risk, which is a category basically a 4 out of 4 on the risk scale, potential risk scale for flash flooding. And marginal is about 5% chance if you want to go look at chances. Once again, low probabilities, high impact event, so low probabilities do matter. Slight risk would be at least a 15% chance. Moderate would be 40% chance, and high risk would be at least 70% chance of seeing that flash flooding. So high risk, you could pretty much expect flooding to occur. Now to look at this, interpreting excessive rainfall, and it's important to know your location on a map, because a lot of these are color-coded. We're going to put out these graphics. They're going to be color-coded for a location. So if you know your location, you can say right away, I live here. Let's say, for example, this is Lake Charles. So I know where Lake Charles is. According to this map, I'm in the moderate area. So what does that mean? That means I have at least a 40% chance of seeing flash flooding within 25 miles of my location. Now for the high risks are very important because they're a big deal. 2/5 of all flood-related fatalities in the United States occur during high-risk days. And about 9/10 of all flood-related damage occurs on high-risk days. So if you get a high risk put out for your area, you're probably going to get flooding, and it's probably going to be dangerous, life-threatening flooding. So you do want to pay attention to when a high risk is issued for your area when it comes to excessive rainfall and flooding. Now, just to look at that, how many high risks are issued per year and so forth? Well, actually, the state of Texas has had more high risk days than any other state in the country over the last 5 years. And Louisiana is number 2. So this area does get a lot of high-risk days, a lot of potential for flooding in this area. We can break it down even by forecast area. So here in the forecast office in Lake Charles, we've been under the frequency of high-risk days for flash flooding more than any other office in the country. So that's pretty incredible that we have that high flood risk around here, which is very important, of course, to know that everybody always says, well, I'm in a flood zone or not. Well, our service hydrologist here basically tells everybody you are in a flood zone if you live in the Lake Charles, Southwest Louisiana, Southeast Texas area. Just because we get those tropical events and we get these high precipitation type events that will flood you out. And so just wanted to let you know that pretty much if you want to know you're in a flood zone around here, yeah, you're probably in a flood zone. So when we start getting, so that's the first process, the risk process. Now we've coordinated with everybody. We pretty much know now we're going to go ahead and issue a flood watch because we pretty much have an idea we're going to get that excessive rainfall. So that means that flooding is possible. So you got to be prepared. Now, when we go ahead and we actually see flooding is about ready to happen, we will issue a flood warning. So flood warning means take action, move to higher ground, and don't drive through those flooded areas. So remember, turn around, don't drown. That's very important because most flood-related deaths do occur when people are trying to drive through those flooded areas. So remember, watch means be prepared. You might get some flooding. And warning means take action. Flooding's about ready to happen. Now, very recently, we actually started to upgrade the flash flood warnings to flash flood emergencies. And we've actually had some of these in our forecast area over the past few years. So basically, we've just talked about the warning. So warning means that the dangerous flash flooding is about ready to happen. So it could flood some homes and the roadways. However, flash flood emergency means these are extremely rare situations. This means that flooding is happening and catastrophic damage is happening, and it's a severe threat to human life. So basically, if you have a flash flood emergency for your area, it's at the upper level, most life-threatening situation you could have. And this means basically do not attempt to travel unless somehow you're told by local authorities need to evacuate immediately to get out before the flooding occurs, because basically that usually means that all the roadways are flooded. And once again, we don't want people traveling to flooded roadways, turn around, don't drown. So flash flood emergencies, very important. That means life-threatening situation. Now the final hazard that comes with tropical systems is our tornado hazard. And with that, we get help from the Storm Prediction Center located in Norman, Oklahoma. They're kind of the experts in severe weather and tornadoes. And what they have is also a kind of a outlook, severe weather outlook. And actually we pretty much had this year also during severe weather season. We've had many times this year, we've had our area outlook and potential for severe weather. And so how do we look at that? Well, to understand this area, we have like a risk scale also, just like we had for the excessive rainfall outlook. And so this scale goes from 1 to 5. So 1, once again, being marginal, 2, slight, 3, enhanced, 4, moderate, and then 5 out of 5 on your risk scale would be high. And once again, for marginal risk, basically another way to look at that is your probability relative to normal. So when we're talking about mainly tropical systems here, that's mainly going to be your tornado probability, those outer bands producing those tornadoes. So on a normal day, you have a 0.2 to 0.4% chance of seeing a tornado at your location, within 25 miles of your location. On a marginal risk day, you have a 2% chance. So actually that's about 10 times greater than normal. So even though you might say, 2% tornado, we don't have to worry about that. Well, that just means that you have a greater risk that day, 10 times greater risk that day of seeing a tornado than you would normally. And a slight risk would be 5%, enhanced 10%, moderate 15% chance of seeing a tornado, and high is 30% chance. So that's extremely greater than normal of seeing a tornado. So that's the way to look at this also, is that relatively to normal. And basically that means so these low probabilities do mean something. Especially a tornado would obviously be a high impact event, could cause severe damage. So low probabilities do matter. Now these convective outlooks are issued basically for a day one outlook, which goes for the next 24 hours. It's issued about 5 times a day. The day 2 outlook is issued 3 times a day, and that goes for the 24 to 8-hour period. You have a day 3 outlook that's issued once a day, basically at 2:30 in the morning. And we have a convective outlook that goes days all the way 4 through 8. So it's a really long-term heads up. That's issued also around 4 a.m. during 4 a.m. Central Daylight Time. Basically, they also do some coordination with the Storm Prediction Center with the local offices. So we can go ahead and, so it's not just them putting this out there, we just regurgitate it. There is coordination goes into this. So there's a lot of thought process goes into it before these outlooks are put out. And once again, what's the difference between a watch and a warning? It's very important to know. So watch means be prepared. So there's conditions out there where a tornado is possible. Now, when we issue a tornado warning, that's a little bit different. Obviously, tornado warning means take action, because on radar, we've seen something forming. We see a tornado out there. So take shelter immediately. Basically, take action. So basically, watch, prepare, warning, action, just like anything else. Watch, prepare, warning, action. So let's look at how do we get the messages? How do we get the effective hurricane messaging for this year? Well, what we like to say here in the National Weather Service is effective hurricane messaging, or any sort of messaging for any sort of impact event, is having the right people take the right action for the right outcome to protect life and property. So basically influence in the outcome of the event in the positive. This doesn't mean have hysteria for everybody, hype everybody up. This just means that the right people that have to take the right action for the right outcome will take that. Now, why is this kind of, tricky? Well, risk perception is always subjective. So for people out there, the probability might be different. Like they say, with 2% probability might mean something to someone, might mean totally nothing to someone else. The consequences, what might occur, once again, based on someone's experience or upbringing, might be different to what someone else thinks. So the actual risk and the perceived risk might not be the same. So it's a lot of times it's very tricky on how to message this to the public. Another thing is risk tolerance. Some people like to take their chances. So that's another thing too. How in the National Weather Service, how do we kind of try to message this so everybody takes some action? Well, what we have here is called the risk tolerance spectrum of plausible outcomes. This is a little bit kind of a weird type graph here, but what it shows right here is the probability of outcomes and how to prepare. So right in the middle here is the official forecast. And so that's basically what's called the 50% exceedance level. Say 50% flip a coin. Well, it doesn't really kind of mean that. What it means is that, and once again, there's no perfect forecast in meteorology. There never has been a perfect forecast, never will be. The mathematics do not allow for it. Too many variables involved, so there's never a perfect forecast. So you're never going to have 100% perfect forecast. So basically, the official forecast is kind of the best science forecast that we can make. That's our best forecast possible that we can make for someone. And so if it's a perfect forecast, 50% of the time, most likely it might be a little bit different. 50% of the time it might be a little bit higher for winds or lower than winds, so forth like that. So basically, this is our best forecast. So this is when most people prepare, when the official forecast says to prepare. Now, we also have what's called the reasonable worst case scenario. So that'd be like 10% of the time this forecast will occur. And this is basically the margin of maximum safety. So this is the better to be safe than sorry forecast. So a lot of times you might be over-prepared or something like that, but that's what we want you to do. We want you to be over-prepared, so make sure you have your maximum margin of safety so you will get through the storm okay. Now, basically, there's also the quote-unquote reasonable best case scenario. But a lot of times we don't forecast that or give that forecast out because then people basically will not take their preparations seriously. There's been studies saying there's an optimism bias in most people. So if you hear that there's a chance that it's not going to happen, then people will say, I'm going to take that chance and I'm not going to prepare because, heck, they say there's a chance it's not going to happen. And basically, during this forecast also, it changes. So this is like about, if I go back to real fast, this is about like maybe 3 to 5 days out. This is when it's best. And this forecast will change. So it might actually become that the forecast we're saying right now, a couple of days later, now it's the reasonable worst case scenario. So those people who are not preparing for the reasonable worst case scenario, now they're in trouble as the event occurs. And so here's an example of how this comes about. So this is an example of Hurricane Delta that occurred back in October of 2020. And this is 2 days before landfall of Hurricane Delta. So here was the official forecast. This is the quote-unquote deterministic or the 50% forecast that we were putting out from the National Weather Service here in Lake Charles. Now remember, with Hurricane Delta, the highest wind gust we recorded here in Lake Charles is 96 miles per hour. So the official forecast 2 days out was for winds in Calcasieu Parish, Lake Charles, 60 to 80 miles per hour sustained, gusts 100 miles per hour. Storm surge 2 to 4 feet, rainfall 2 to 4 inches, so forth. Tornado threat marginal. But 2 days out, there was a possibility that we could have a major hurricane coming up this way. So what we have right here is the prepare for maximum safety forecast. So that's the reasonable worst case scenario. And the way this forecast is produced or we put out to the public or share to the public is something called the hurricane threat impact graphic. So this was showing 2 days out that we could have potential for 110 mile per hour winds or greater across southwest Louisiana, south central Louisiana. So this was the forecast we were telling people to prepare for. So you want maximum safety, you want to be sure to be prepared for something, prepare for the 110 mile per hour winds. But we think our best forecast is, best science says we're probably going to get gusts close to 100 miles per hour. And actually, in this case, the official forecast was pretty close to being right on the money. Now, once again, the hurricane threat impact graphs, let's go through some of them just to explain that once again. This was for Ida last year, example of that. So this, once again, is the potential risk. And what it is the probability, since there's never 100% certainty, there's always a little bit of uncertainty in there. So you take the probability with the consequence, obviously high consequences for a hurricane type event, and the vulnerability. You put it all together, you come up with this risk here. And this is for the maximum. How do you prepare for these conditions for maximum safety? So, for example, with Ida, we're telling people pretty much in the south central, southeast Louisiana area, prepare for those major catastrophic hurricane force winds. Here in Lake Charles, we're telling people maybe you get some tropical storm force winds over here. If you prepare for tropical storm force winds, you'll be definitely prepared for anything that might happen. Now, obviously, during the Ida event, we actually did not get tropical storm force winds, but if you were prepared for it, you were prepared for it. Same thing goes for storm surge. We do the same thing for the storm surge product. Once again, this will be the potential risk that you have. So anywhere in purple, this was actually before Hurricane Laura. Anywhere in the purple here, you should be prepared for flooding above 9 feet above ground level. Now on the red up here to Lake Charles, we even had like a little bit of possibly getting 6 feet above ground level. And if you remember, during Laura, the eye came in just east of Cameron Parish, or in that area, or east of Cameron, I should say. So the eastern part of the parish there got the highest storm surge. So on the west side, they didn't really get the 6 to 9 foot storm surge. But being a couple of days out, you want to be prepared for for your reasonable worst case scenario. Prepare for maximum safety. So this threat also goes through for the flood threat. So here, get my clicker working. There we go. So in this scenario right here, the Beaumont area, Southeast Texas, you're underneath potential for extreme flooding, where the rest of the area is kind of on the potential for major flooding. So basically, once again, everybody in this area would really need to prepare for flooding to occur. This was back in September of 2021. So this was a tropical storm event that occurred where a tropical storm was moving up slowly from Houston's area into the Southeast Texas area and eventually went across Southwest Louisiana. And this was we also do that threat for the tornadoes. And so with Hurricane Ida, we were telling everybody pretty much east of the 49 corridor, there's a possibility of getting tornadoes with Ida. Now, obviously, Ida landfall east of Morgan City, so those outer bands producing tornadoes were further to the east of the area. Once again, when we're talking about maximum safety, we're talking about a few days out. We want to, there's a little bit of uncertainty in there, so we have to forecast that uncertainty, and this is the way we do it. Now we can go into the challenges. How do we get this message out there? And the main thing we like to say is having one voice. So this is a takeaway from every single post-storm surveys we've done on big high-impact events, is that if there's a unified voice, then people will take action. Then it's unified voices, local emergency management people, state and federal government, the local media, also even the national outlets like the Weather Channel and so forth, and our local National Weather Service office and National Hurricane Center and so forth. If everybody has the same message, then people are more likely to take the action to protect life and property. Although we like to say, having the right people take the right action for the right outcome. And it's also, if everybody has the unified voice, there's no confusion, then people are less likely to look for those keyboard meteorologists and those rumors out there and so forth, look for unreliable sources to know what to do. So once again, this is kind of just a graph of showing that the 3 routes here at the National Weather Service we take to message for high impact events. Through like our Facebook Lives, our posts on our social media sites, our webpage, basically we talk directly to the public that way. So that's why it's very important that Donald does these Facebook Lives, so we can, the message that we want to convey, that the forecasters here at the National Weather Service office in Lake Charles want to convey to the public, that for sure we know at least those people are getting that if they watch this Facebook Lives. Now hopefully, and we have good relationships with the local emergency management people and the media. So we get those products too. We do briefings to the local emergency management community when these events are going to happen. And they will then convey that message to the public also. And of course, the local media. And once again, we have pretty good relationships with the local media too. When they're in high impact events, we kind of also have the same voice. They will message the same hazards that we are messaging. And that way, everybody in the public will be getting the same message and acting on the same, taking the same preparations to save life and property. So how do we do this? Well, basically it's trust. We got to build those trusts, those relationships before an event happens. That's one of the reasons why we're doing this right now at the start of the hurricane season, before we get an event into the Lake Charles area, is that just to let you know that we do have people here, forecasters here at the National Weather Service office here in Lake Charles, that really do care about the area. We do live in the community. So we are going to try to make the best forecasts for you to prepare. And also we will message that, what the reasonable worst case scenario will be, so you can be prepared for that and be able to make the choice to make for maximum safety. And that's why Donald is very good at doing that also, because he's built up a good trust with the community around here, which is very good to see. And we all like that very much, that he has his followers out here, because you'll help us out also. When you tell other people, when you see those fake posts or whatever out, those rumors out there, I see you guys out there, you'll tell them and say, hey, I saw Donald Jones on Facebook Live, National Weather Service, and here's the information. This is what's going to happen. So it's building trust for the events. Also with the emergency management community, I've actually done a few talks out there already this year. Going to be doing another one next week. So we want to, meet our partners in the emergency management community, the law enforcement community, so they know who we are and that we are serious about this. We take this seriously. And the same thing goes with the media too. So what's the general message and takeaways from this? We want to tell you to focus on the hazards and the impacts, not necessarily the track, the cone, and the category of the system. Focus on what the hazards and the impacts are going to be for your area. Every storm is different, so that's very important. You might have lived through a hurricane that happened like 30 years ago and said, oh, I lived through a hurricane such and such 30 years ago. My house was fine, nothing happened. Well, this storm could be different. It could be a lot stronger as far as winds. You might actually get the eye wall this time. You might have 50 inches of rain. Last time you only had 10 inches of rain, so forth. So every storm is different. So you got to remain focused on the hazards. Also, remain focused on the water hazards and the storm surge hazards, even though the wind scale category changes. So let's say we had a category 3 about ready to hit landfall, and it starts to weaken some, so now it's down to category 1. So you're like, well, we're off the hook. You're only going to be a category 1. Now, maybe now it's moving slower. Now it's going to produce 40 to 60 inches of rain. Obviously, you're still going to have a big flood hazard. So just because the category is decreasing doesn't mean that the threat or the hazard is also decreasing. Also remember that significant impacts occur far from the center. So hurricane's not a dot. It's not just a center. And also regularly occur outside the cone. So that's very important to remember. Also, look out for the bad information from the keyboard meteorologists out there. So encourage people to share only information from reliable sources, like here the National Weather Service office, and those people out there that's in local media and the local emergency management community that you really trust. Share that information, because one voice, that's the way to go. One voice, people are more likely to take the action to protect life and property. Now, I want to talk about here also is something very important: rapid intensification. That's a lot of these monster storms. That's what happens. They rapidly intensify. Here's a map that Brian McNulty at the University of Miami Tropical Research Center made. And basically, here's every Category 5 hurricane hit the U.S. all the way back from Labor Day in 1935, I should say in recorded history, back in Labor Day in 1935, through Camille, Andrew, Michael. And what's noticeable about here is that 3 days out, every system looked like nothing. It's either a tropical depression or tropical storm. So they were not very impressive. So that's very important to note, that just because a system doesn't look so forth impressive, especially if we're forecasting rapid intensification, it's very important to take note of that. So for example, if we look at Hurricane Laura example here, less than 72 hours before landfall here in the Gulf of Mexico, it was only a tropical storm. It didn't look very impressive at all. But we were forecasting it to be a major hurricane as it reached landfall. So it's very important to pay attention to the forecast also, and not just what the system is at the current time. So I know there's people out there at that time saying, it doesn't look that bad, we'll wait and see, and so forth. But we knew the conditions were right here in this area for it to rapidly intensify, and that's exactly what it did. Now for last year, the same thing happened with Hurricane Ida. Hurricane Ida, 48 hours before landfall exactly, once again, it was just Tropical Storm Ida near Cuba. But once again, the forecast had it been going to a major hurricane before landfall, because once again, we had the conditions out here, very warm. We call it high ocean heat content, where it's very warm deep waters, and we have very low shear. Perfect conditions for rapid intensification, and that's exactly what happened. Ida became a major hurricane before landfall. So it's very important. Just because 2 or 3 days out before landfall, it doesn't look much on satellite picture. You look at the latest advisory, you're like, 70-mile-per-hour winds, I'm okay, I'm not going to worry about that. But if the forecast says it's going to get to major hurricane, you better pay attention and be preparing for that. Now, I just want to give you the slide right here, give you a minute here. These are all the web resources you can use for this upcoming hurricane season. Of course, for the National Weather Service, our Lake Charles, our homepage is weather.gov/LANT-LCH. And our front page there, we'll upgrade you with graphics, get the links to the latest tropical weather advisories, our latest forecast, point-and-click forecast, everything will be on that page. Also, always see if you're looking at Facebook right now, you know about getting us on Facebook, get us on Twitter and so forth. Now here's the National Hurricane Center address, nhc.noaa.gov. If you want to go directly to the Hurricane Center, look at the latest advisories and all those graphics. Also, you can search for them on social media too. They do a lot of Facebook type stuff. I know Ken Graham, if there's a big event, big hurricane about ready to hit landfall, he'll also do Facebook Lives. Storm Prediction Center, to get their outlooks, rural outlooks, you can go to spc.noaa.gov. Weather Prediction Center, to get those excessive rainfall outlooks, you can go to wpc.ncep.noaa.gov. If you live along the coast there, you need to know your tide data. The National Ocean Survey has tidewater level locations along the coast there. You just go to tidesandcurrents.noaa.gov, and you click on location there, the closest tide location to you, and you get that information. And also, if you live near a river, you want to know what the river stage or river flood warnings are going to be and stuff like that, you just go to water.weather.gov/AHPS, and you get the latest information on the river stages and river flood warnings for your location. So as we come to the end here, we will look at there we go. Basically, that's all I have for this presentation right here. So for hurricane season, we want you to be prepared, be smart. Let's hope everyone has a good hurricane season, right? Good means, you know what? Your favorite alcohol beverages. Bad means hurricanes. We don't want that here. So, and with that, we'll open it up to any questions or comments you might have. Donald's still here with me, so fire away.
The first question we got, Don Derry wants to know how computer systems track what's guiding the storm. He says, I know it's warm water and winds, but that doesn't account for when storms have a sudden shift. So how do these applications track and predict the pathway of storms?
Okay, well, basically what it is that we have the supercomputers out there. We have one at Silver Springs, Maryland. That's the American miles are run there. Some of the academic locations around the country have the supercomputer locations also, and around the world. So what they do, they take data. So basically here at the weather office in Lake Charles, we launch a balloon twice a day at 6 a.m. and 6 p.m. And everybody else around the world does it at the same time. So all this data goes into these supercomputers. And so what happens is that these supercomputers take all the mathematical equations known that science has come up with on how to predict weather phenomena, weather situations. So what happens is that the data goes in there and the computer run comes out. And like I said, there's many just one computer model run. So even like the GFS model has like 50 runs of the GFS model. So what happens is that all the mathematical equations go in there and the computer spits out where the tracks are going to be, where the low pressure is going to be, where the high pressure is going to form. So let's say that a low center is going to form near the Yucatan, like in this situation is. Computer model is going to look at that and say, okay, there's a trough coming down from the north. So if the trough comes down from the north, southwest winds develop ahead of it. So it's going to push that little center there in the Yucatan off to the northeast. So what happens, let's say that 2 days or 3 days from now, something changes. The data that's going in there has changed. We get more data. We start getting the hurricane hunters out there. Start getting some of the G4 aircraft flying around. We get more upper air data. We get more balloon launches. So the more data that goes in there, better chance of getting a better forecast. So these forecasts then become fine-tuned because now there's more information for the computer models to run. So basically like anything else, if you put garbage in, you get garbage out. You put good data in, you get good data out. So I hope that answers the question there.
The other question, also by Don Derry earlier, was what is the likelihood of La Nina going into a neutral pattern over the course of this hurricane season?
As we kind of changed it, at first we were kind of confident, most of the guidance out there, the climatologists who really study the phenomena of La Nina and El Nino, the ENSO event, so to speak, we're pretty confident that it was actually going to go to a neutral pattern around the fall timeframe, so in September, October timeframe. Now lately, unfortunately, a lot of the guidance out there now, it's shifting a little bit, that it might actually stay a La Nina for the rest of the hurricane season. So I'd say right now it's pretty much 50-50. It's going to go neutral or stay as La Nina.
Really all the questions we have. Dane wants to know what methods will we use to advise people if a hurricane threatens the Gulf?
Okay, like we're saying right there, you'll have the different products we put out. So the first product we want to issue is the tropical weather outlook. So basically, if we look at that product and we see an area in the Gulf or potential area in the Gulf that could develop, that's when we started looking at that and say, okay, we gotta start paying attention. So what's our probability of it? And what's the formation location gonna be? So then we'll start to put out these products. We'll start maybe doing some Facebook Lives. We'll start, in our forecast products we put out, we'll start mentioning, hey, there's a possibility of tropical formation in an area. And we'll start doing that with our emergency management community. We'll send out emails each day to the emergency management community saying, hey, we got something that we're looking at right now. You guys need to start paying attention. And obviously, as the event evolves and we start to know that more certainty that something's going to develop, then we'll start doing the advisories. Then we'll start messaging where the impacts might be and so forth.
When wants to know if we get a certificate after this class?
Well, we should have thought about that. Just know in your heart that we appreciate you watching this whole presentation and going through just to learn the process. Like I said, sometimes, even though we've lived through many hurricanes, like I said, I've been here in Lake Charles since 1995. So I've lived through Rita, I've lived through Ike, obviously Laura, lived through Delta, lived through like Tropical Storm Allison, Harvey, Imelda. So basically 3 of the top 5 wettest events in U.S. history. I've forecast through those. So even though we've all done this, it's always nice to refresher about how to use the products. Because sometimes you hear products differently and some people might interpret it differently. So it's good to just a refresher about how we want you to use those products. Because it's better for us if we can message it better to you guys. And also you guys then can also help us out by messaging that to your friends and family and so forth. All right, well, I guess we can go ahead and end that. I really do appreciate everybody that stayed on and listened to this whole presentation. I know it's kind of long and so forth. So but I really do appreciate that. Like I said, let's hope we have a pretty quiet year this year. Thanks a lot.